Welcome back. Alright, so now we understand what all went into the thinking as to, well, okay, how much carbon dioxide do we think is going to be in the atmosphere in the year 2070 or 2075 or 2080 or whatever year you want to figure it out. We can use the science and understanding of the IPAT relationship and understanding of things like population change and affluence change and so on in order to come up with these estimates. That's what those emission scenarios that we learned back 2 modules ago or something were about. Where all those future projections of population, affluence, and energy intensity and carbon intensity were put into those estimates. But they all have some measure of uncertainty, and that's why we had to produce different scenarios. What if it goes this way? What if it goes that way? What if population continues to grow until the year 2100? What if affluence falls because of international conflict, etc.? I mean, after all, maybe the climate isn't all that sensitive to this stuff. This is what we need models for. We need to know if that matters. If it doesn't really matter what the population is, that's something that we should know before we, if we end up with the same amount of climate change, whether the population is 8 billion or 12 billion, well, then population isn't something that needs to be worried about, at least not in a climate change sense. Alright, so we start developing all these different scenarios. Now, you remember these guys from a couple of modules ago. This is like A1, A2, B1, and B2. You might not remember which one is which, and so on. But we have a little verbiage that I just want to take straight from the textbook here. Your textbook has descriptions of this that are they're taking a slightly different spin on what is meant by A1, A2, B1, and B2 than the set of notes that I got for the scenarios lecture. So let me just give you their exact verbiage here, but I do want you to read that part of the chapter yourself. It says here in the first printing of the textbook, this is the storyline that describes a future world with rapid economic growth, where both the rich and the poor experience gains in wealth, leading to a reduction in the wealth gap between the rich and the poor, and a decrease in poverty. That doesn't sound so bad. Because of the wealth gains in the poor, the population growth slows down, and global population peaks in about the year 2050, and then declines thereafter. There's also rapid introduction of new and more efficient technologies. Alright, so this is the path that seems most like what we're on, right? In general, the poor countries seem to be gaining. Obviously, disparity of wealth is still an important issue, but overall, we are elevating people out of poverty, but doing so by burning fossil fuels and so on, and also large economic growth. That's different from A2. This is the storyline that also describes a world of high economic growth, but the wealth is very unevenly distributed, with the rich getting richer and the poor remaining poor. That is both like within countries and like the difference between rich countries and poor countries. Okay, there's going to be a high birth rate. There's going to be populations that continue to grow, therefore, throughout the 21st century. And because of uneven economic growth, technological development is slower than in other storylines, with deployment of new technologies occurring mainly in the richer parts of the world. Within the A2 storyline, then there'll be a variety of scenarios as to how this happened. Usually things like conflict. A trade war between the United States and China destroys international trade. Okay, and then we end up with this more compartmentalized, less globalized economy and so on. Or it can be an actual war, or it can be, they have various scenarios within the A2 storyline. B2 was the Star Trek storyline, where, like, a happy future where all share and money it's not quite that happy, but this storyline describes a world where economic growth is evenly distributed between the rich and the poor. Economic growth is slower than in the A1 scenario because of an emphasis on sustainable growth and environmental protection. It has the same global population that peaks around the mid-21st century and then declines just like the A1 storyline. The world economy shifts towards service and information with associated reductions in energy intensity and the introduction of clean and resource-efficient technologies. Darn, that sounds like the best world. Okay? That's slow economic growth, but we share the wealth more evenly, both like within this country and between rich countries and poor, cooperating towards finding a sustainable future. Doesn't that sound lovely? B2 storyline is a storyline that describes a world where the economic growth is unevenly distributed, where the rich get richer, the poor remain poor, population increases, although at a slower rate than in A2. Sustainability and environmental protection remain the focus, but only at regional levels. Again, within the B2 storyline, there were individual scenarios that involve things like regional nuclear conflict or collapse of China's economy and things like that. But the basic idea is that the globalized economy is given up more for regionalized, slower growing parts of the economy. What might not have been at all clear in the original scenarios lecture here is that there's a pattern to these four storylines here. The ones that start with the letter A are all patterns that are about high economic growth, whereas the scenarios and storylines that start with B are all about very slow growth. Okay, and there's a pattern to the numbers as well. The ones that have a 1 in them have a gradually narrowing gap between the rich and the poor, whereas the ones that end at a 2 have a gap that stays the same or even widens. And so we have kind of 4 different sets of scenarios and storylines here, depending on whether they're A's and 1s and B's and 2s and so on. And they deliberately chose just letters and numbers like this, so there's no value judgment placed on these. This isn't, for example, the A1B storyline is one of the storyline scenarios within the A1 storyline. Is often called the business as usual storyline, but that's kind of a judgmental thing, right? I mean, whose business is this that's going on as usual? What about the people who it wasn't like that in the past? The IPCC rather aggressively works to avoid those kinds of terms. Well, then you can put all these storylines and all these scenarios, and you can figure out, based on the IPAT relationship, how much at any given year they're emitting, and you get a graph like this that shows the amount of carbon being emitted each year in each of those scenarios. And if you actually take a look, I put a solid line there that shows the 1990 carbon dioxide emission level in there in the red line, and if you actually look at it, only the very most optimistic scenarios, A1T, in which technology is mainly used to produce green energy rather than video games and gadgets and so on, and the B1 scenario, the Star Trek future, are the only ones that the emissions ever even get as low as they were in 1990. We were already worried about emissions in 1990. 1990 emissions aren't good, and actually almost all these scenarios never get anywhere near that good again. That's bad news. B1 does manage to have the lowest emissions due to its relatively low population and due to its high focus on sustainability and green technology and so on. But some of these are just disasters. I mean, here's the average of A2 scenarios. It has high population and high inequality, and as a consequence, when new technologies come out, the countries don't share them and so on. And the A2 average is just terrible. I mean, the amount of carbon dioxide being emitted each year by society is just completely unsustainable there. Those are just the emissions, though. Remember, every year the emissions add up to the previous emissions, right? I mean, we're just building and building and building. And when you pick a diagram like this that shows the amount of carbon dioxide actually in the atmosphere in each of those scenarios here, I highlighted with the red line there the pre-industrial concentrations of carbon dioxide at about 280 parts per million. What you see is, by the time you get out to the year 2100, not only are all the scenarios way higher than the pre-industrial values of carbon dioxide, but they're huge and they have a wide spread. I mean, we really actually could have very large differences in the amount of radiative forcing that's going on. And with that amount of carbon dioxide, we can actually compute the radiative forcing, just like we did in an earlier module. And you get the horrifying numbers that fall in the range of 4 to 8 watts per square meter. A positive radiative forcing of 4 to 8 watts per square meter by the end of the 21st century. Now, I don't know if you happen to remember the kinds of numbers we were doing when we did radiative forcing, but most of those numbers were like 0.5 or 0.8 or negative 1.1 or something. These are huge. The total net radiative forcing by all that carbon dioxide by the end of the 21st century is huge, even in the really optimistic scenarios. This is terrible. This is a huge radiative forcing. It would be among the biggest radiative forcing events of the last 500 million years on Earth. Okay, think of all the times we've had major volcanic eruptions and been hit by a comet and God knows what else. This would be among the very largest of all that time. And while it's true that that radiative forcing that's driving the climate there is caused by aerosols and methane and carbon dioxide and stratospheric water vapor and so on, it turns out that about 80% of that radiative forcing is due to anthropogenic carbon dioxide. That's a factor that we can control. This is a terrible number. 4 to 8 watts per square meter is unbelievable. It's end of the world bad. But it is something we have some control over. We can decide where in those outcomes we want to be. And we will. But first we want to take some questions. Question 4. By the year 2100, the scenarios with the lowest carbon dioxide concentrations in the atmosphere are the ones with blank population and a blank economic gap between the rich and the poor. Is it a high or a low population, and it is a large or a small economic gap between the rich and the poor? Make a choice from those 4 options and get a little feedback before you move on to question 5.